Hi, we need to solve this differential equation, but to get the separation of variables, we're going to introduce something called integrating factor. And in this case, it's 1 over xy. And you'll see how this helps to separate the variables. We multiply this expression by 1 over xy, and we have 1 add x over x dx. Oh, by the way, and then we're multiplying each of these expressions by dx. So first we multiply by the integrating factor and 1 over xy, and then both of these expressions by dx. And this will give us 1 minus y over y dy equal to 0. So here the dx cancels when we multiply by dx. In this case it stays, but it cancels the y, we're left with x. Here we cancel the y and we're left, the x, and we're left with y. Now we can integrate. We can express this as 1 add 1 over x dx, and this as the integral of 1 over y minus 1 dy is equal to 0. And from this we have ln x add x add ln y, the modulus of these two, x and y, and minus y. So when we integrate minus 1, we have minus y. We integrate 1, we have x. We integrate 1 over x, we have ln x, the modulus of x, and 1 over y is ln the modulus of y. And this is equal to c. Now if we just simplify this, first we write ln modulus of x add ln modulus y, and then we have x minus y added to x minus y. We just write this clear, this is just brackets here, equals 0. Now if we simplify these logs, we have the sum of two logs here. We can write them as a product of these logs as ln the modulus of x y. So that simplifies it, and we're adding x minus y, and it's equal to an arbitrary constant. Thanks for watching. I'm Alistair.